Section 11.2, Simplify Radical Expressions. A radical expression is in simplest form if no perfect square factors other than 1 are in the radicand, so underneath the radical symbol, no fractions are in the radicand, and no radicals appear in the denominator of a fraction. So the product property of radicals says that the square root of a times b is equal to the square root of a times the square root of b. In other words, whenever you have a radical of a product, you can split it up into the product of two separate radicals. And then we're also going to use the fact that the square root of a squared is equal to a, when a is greater than or equal to 0, to help us simplify radical expressions. So in the first example, we're going to simplify the square root of 48. So the square root of 48 is the square root of 16 times 3, because 16 times 3 is 48. And then we're going to split this up, so we have the square root of 16 times the square root of 3. The square root of 16 is 4, and then times the square root of 3. If you don't know that 48 is equal to the square root of 16 times 3, so 48 is 16 times 3, you have two different ways you can do it. You can try to divide out perfect squares, starting with maybe 4. Perfect squares are going to be like 2 times 2, 3 times 3, 4 times 4. So you could do 4, 9, 16, 25, 36, and see what this goes into this. The other thing you can do is prime factorization. So 48 is 6 times 8. And then we're going to break that down. 6 is 2 times 3. And 8 is 2 times 4. And then 4 is 2 times 2. So 48 equals 2 times 2 times 2 times 2 times 3. 2 and 3 are both prime numbers because the only factors of them are 1 in themselves. So then what you could do is you could look at 2 times 2 is 4. 2 times 2 is 4. So you could rewrite this as the square root of 4 times 4 times 3, which would be the square root of 4 times the square root of 4 times the square root of 3, separating our radicals. Square root of 4 is 2. Square root of 4 is 2. And I'm still multiplying everything. And then 2 times 2 would be 4. So that'd be another way you could get there. You could also look here that you have, well, 4 times 4. Okay, so I can pull out a 4 because the square root of 4 times 4 is 4. The next example is 25x to the 5th. So first we're going to split this up. Square root of 25 times the square root of x to the 5th. Then I'm going to take the square root of 25 to get 5. And now I need to figure out how to take the square root of x to the 5th. So what I'm going to do is I'm going to write x to the 5th as x squared times x. I know if I write them in terms of x squared, I know that the square root of x squared is going to just give me x. So that's why I'm writing it this way. I'm going to split these all up. The square root of x squared is x. Square root of x squared is x. And then I have the square root of x. X times x is x squared. So I have 5x squared times the square root of x as my answer. So another property we have for radicals is our quotient property. That says the square root of a quotient equals the quotient of the square roots of the numerator and denominator. So the square root of a over b is equal to the square root of a over the square root of b. As long as a is greater than or equal to 0 and b is greater than 0. You can never take the square root of a negative number, which is why a is greater than or equal to 0, because we can take the square root of 0. B can't be equal to 0 because it's in the denominator and we cannot divide by 0. Okay, so then we're going to use the quotient property of radicals. Okay, so square root of 549, so we're going to split that up to be the square root of 5 over the square root of 49. The square root of 49 is 7. And then we're just going to leave the numerator as the square root of 5 because we can't simplify that further. It's okay to have a radical in the numerator, you just cannot leave it in the denominator. So we're going to split this up, square root of 11 over the square root of d to the 4th. This is going to be square root of d squared times d squared. And then we can split those up. The square root of d squared is just d. And the square root of d squared is d. So I end up getting the square root of 11 over d squared. Okay, and then I just want to go back to an example on multiplying radicals that I skipped. We're just going to simplify these. Okay, to simplify the square root of 7 times the square root of 7, we're going to put it under the same radical. Then we're going to go ahead and multiply. And then the square root of 49 is just 7. So same thing here. The 3 is going to stay out front because it's not underneath the radical. And then we're going to multiply the two terms underneath the radical. Then we're going to simplify this because b4 to the 4th can be simplified. So I'm going to write it as b squared times b squared. Square root of b squared is b. Square root of b squared is b. And then b times b is b squared. So I have 3b squared times the square root of 2. And then same thing here as in the last example. I'm just going to multiply what's underneath the radicals. So I have 5, and then I have m squared times m. It's m cubed. N squared. And then I'm going to simplify this. Just going to rewrite m squared. M cubed is m squared times m. I'm going to separate these. And then I'm going to take the square roots I can. I can't take the square root of 5, but the square root of m squared is going to be m. Square root of n squared is going to be n. And then I'm left with 5m underneath the radical. So the process of eliminating a radical from an expression's denominator is called rationalizing a denominator. Okay, so to get rid of the square root of 6 in the denominator, I'm going to use the property that the square root of a squared equals a, as long as a is greater than or equal to 0. So if I can have the square root of 6 squared, it's just going to become 6. So in order to get that, I'm going to multiply this by the square root of 6, because now I have the square root of 6 times the square root of 6, or the square root of 6 squared. And so I will just get 6. But in order to not change the value of my fraction, I have to multiply the same number on top that I multiplied on bottom. So I end up getting 7 times the square root of 6 over 6. Same thing here. I want to eliminate the radical in my denominator, so I multiply it by itself. When I do, the denominator just becomes 5a. And the numerator, we do 3 times 5a underneath the radical. So we get square root of 15a all over 5a. So you can use the distributive property to simplify sums and differences of radical expressions when the expressions have the same radicand. So when the same number is underneath the radical, because then they become like terms. It's just like when you have a variable where you have to have your like terms. So we have 7 times the square root of 14 plus the square root of 21 minus 4 times the square root of 14. So in order to add or subtract the radicals, we can only combine the ones that have the same number underneath the radical symbol. So then we're just going to add or subtract their coefficients. So 7 minus 4 is 3. So I have 3 square root of 14s plus I have the square root of 21. Okay, so this one, it doesn't appear that you can combine anything, but we can simplify the square root of 28. The square root of 28 is the same as the square root of 4 times 7. And then we have the square root of 4 times the square root of 7. The square root of 4 is 2. So now I have the same numbers underneath the radical symbols. So now I'm just going to add the numbers in front to figure out how many square root of 7s I have. I have 2 square root of 7s plus 2 more square root of 7s. So together I have 4 square root of 7s. Okay, then multiplying radical expressions. Here you're just going to distribute the square root of 3. So I have 2 times the square root of 3. We always write the number that's not under the radical first, and then we write the radical. And then we have the square root of 3 times 12. 3 times 12 is 36. And then the square root of 36 is 6. So that would be your answer for that one. The next one so we have the square root of 2 plus the square root of 5 times the square root of 2 minus 3 times the square root of 5. So this one we're going to multiply out the same way you multiplied out binomials. So you can use FOIL, you can do it vertically, you can do it horizontally, you can use the distributive property. I'm just going to go ahead and do FOIL. So I have the square root of 2 times the square root of 2. That's my first terms. Then my outer terms are the square root of 2 times the negative square root of 3. Negative 3 square root of 5. You can make that a plus a negative if it helps. My next term is square root of 5 times the square root of 2. And then the last term is the square root of 5 times negative 3 square root of 5. Now I'm going to go ahead and multiply these, and then I'm going to try to combine any like terms I can and simplify it. Square root of 2 times the square root of 2 is the square root of 4, or just 2. It's the square root of 2 squared. This one here becomes minus 3, and we're going to multiply the two numbers underneath the radicals. So it's 2 times 5 is 10, so it's 3 square root of 10. This one here, again, we're going to multiply the 5 and the 2 because they're both under the radical. So plus the square root of 10. And then here I have minus 3 times the square root of 5 times the square root of 5, or the square root of 5 squared is just 5. These are like terms. So I have 3 square root of 10s plus 1 more square root of 10. Sorry, I have negative 3 square root of 10s plus 1 square root of 10. So that's negative 2 square root of 10 minus 15. And then I'm going to combine my 2 and my minus 15 to get negative 13 minus 2 square root of 10.